Hi everybody and welcome to a new video in the Generative Music AI course. Last time I introduced generative music from a very high level perspective. Today I'm going to bring you on a journey, and that's the history of generative music. I'm going to introduce 5 different eras of generative music that I came up with, and these eras are there to make sense of the complexity and the historical events packed into the history of this discipline. Throughout these eras, I'm going to also show you some notable examples. Let's get into these 5 different eras. I want to give you an overview at the beginning, and then we're going to go into each one of these one by one. Okay, so the first era is the pre-computer era. So composers used to use algorithms before computers were around, and they used these algorithms to generate music, to compose music. This era goes back to the 18th century and it arrives until the middle of the 20th century. The second era is called the academic era. It lasts for 50 years and it arrives until 2009. Then we have the third era, and I call this the first startup wave. After that, from 2017 until 2022, we have an era that I call big tech experiments. And finally, starting from this year, the year I'm publishing this video, that's 2023, we have an era of music AI hype. So let's dive into each one of these eras and break them down. Okay, we'll start from the beginning, pre-computer era. This moves from the 18th century, more or less, and it arrives until 1956. So what are the main characteristics here? So as I mentioned earlier, composers lead the charge here, and they use manual algorithms to come up with music. They use different techniques, like for example, randomness or recombinations or pre-created sections or bars, and we'll see an example of that. That's super cool. And they also use algorithms to derive various musical parameters, like for example, they come up with notes, with rhythms, durations, or articulations. And there's also another cool example about this. Let's get started with the first example that I have for you for the pre-computer era, and that comes from His Majesty Wolfgang Amadeus Mozart. And Mozart wrote this piece, this composition, but it's really more than a linear composition. It's called the Mozart Dice Game, and it published it in 1787. So what's this thing all about? Well, you can use random recombinations of 176 pre-composed bars in order to come up with different sequences to create a lot of different compositions. So you roll the dice and you select the bars. So let me show you an implementation of the Mozart Dice Game. Here you have all the different bars, and you can generate another sequence like this, and then you can just like play it. So let's listen to this. So we start here, then we move here, up here. You get the point, right? So if you want something new, you just regenerate, and behind the scenes we have just like some random based algorithm that chooses among like the different options, and you get a different composition. You get the idea. So the bars are written in such a way that they make sense together regardless of the particular arrangement. Another composition that I really love from this pre-computer era is one called Mode de valeur et d'intensité by the French composer Olivier Messiaen. And that is from 1949. So how does this work? Well, Messiaen utilizes a parameterization of different musical variables, like for example, dynamics, articulation, pitch, and duration. And it comes up with an algorithm to select all of these musical elements that have been parameterized. Let's quickly listen to an interpretation of a short excerpt of this composition. So here you have the instructions by Messiaen. Here you can also see like the parameterization of all the different things, like for example here the articulations, here the dynamics or the intensities, if you will. Here there's the parameterization of all the different durations. And okay, yeah, let's move on to the music. Yeah, of course, this type of music is very contemporary in its aesthetics. Next, we have the academic era that goes from 1957 until 2009. And as the name of this era suggests, research in this case is done within an academic environment, within universities. This period lasts for more or less 50 years, and it's the first time where we have people actively creating music with computers. Let's take a look at some of the characteristics of this era. First of all, in terms of the research activity, there's a lot of experimentation. People are trying to draw all possible techniques from AI and adjust them to have computers create music. But the advancements tend to be quite incremental, and overall there's a quite scattered community. What I mean by that is that there isn't necessarily a unified platform for generative music researchers. You have people from different disciplines, like for example from computer science, AI, music composition, music cognition, who work on algorithmic composition and generative music, but there isn't necessarily a single forum where like people can collaborate together. In terms of the musical output, the majority of the algorithm created don't necessarily focus on the generation of full musical pieces, but rather on part of it. Like for example, generating melodies or chord progression generations. These are more or less like the tasks that get tackled the most. There isn't really a big focus and interest on audio production quality. And one of the reasons why that's the case is because these models tend to work in a symbolic environment. In other words, like they generate a score, like a MIDI score. There isn't really a performance of those models. It's more, here's the score, then if you want, you can perform it with human musicians. And finally, I would say that most of these experiments gravitate around classical music. This is not 100% true, of course. There are exceptions. There's substantial experimentation also like with EDM, for example, or other styles, but most of the people would focus mainly on classical music. And one of the reasons is also like because classical music datasets are quite available. During this era, we have the first composition generated by a computer. And from what we know, that composition is the iliac suite, and this iliac engine algorithm was developed by two composers, two researchers at the University of Illinois, and they are Hiller and Isaacson, and they published this composition in 1957. So what is this composition about? It is a string quartet. It's divided into 4 different movements, and for each movement they used different techniques like generative grammars or Markov chains. Okay, let's listen to the iliac suite, just like a short passage, and if you want, you can definitely find this on YouTube. Okay, I guess you get the idea of that, and again, the gist here is quite contemporary, but it's super cool. I definitely suggest you to check this composition out because it's quite amazing. The second example that I want to bring from the academic era is experiments in musical intelligence, or EMI. This algorithm was developed by David Cope, a composer based in California, in 1981. Cope invented this algorithm because he had a composer's block and he wanted just like to continue compose music, but he was completely stuck. And so he thought, why don't I create an algorithm that knows about my musical style and helps me create music in my style. And so that was the inception of this idea. The cool thing about EMI is that it generates full musical pieces, and it uses a recombination approach that works in 3 steps. First, you just feed the corpus, so all of the scores that you're interested in, for example, all the music by Beethoven or Chopin, and you feed all of this music into the algorithm. The algorithm extracts some signatures, some passages that it thinks are very important for the style of this particular composer, and then it uses some techniques that help like recombine all of these elements, all of these signatures that it previously extracted, and so that you can come up with something new that is very connected with the style of the corpus that you've used to train the algorithm. Okay, let's take a look at one of the compositions created or generated by EMI. The composition we'll listen to is in the style of a Bach chorale, and it's performed by humans. Quite impressive, isn't it? Next, we have the third era that I call the first startup wave. This one goes from 2010 until 2016. And the main point here is that we have a lot of generative music startups that get on the market. The focus of these startups shifts from research to products. They want to build products that people can actually use to have fun with music. So rather than focusing on parts of the musical composition task, they tend to opt for full piece generation. And a cool thing that pops up during this period is that these startups start to put together high quality music datasets that they leverage with their machine learning algorithms. And this is another thing, like another shift from the academic era. While in the academic era, there was a lot of experimentation with good old-fashioned AI. In this case, in the first startup wave era, there's a lot of use of machine learning algorithms. Here you have a bunch of examples of startups that were active during the first startup wave, and here I'm just going to highlight like the startup that I co-founded, and that is MelodiDrive. We co-founded MelodiDrive in 2016, and what we did was a real-time video game music generation, and we had the music that would adapt in real time to the game context and change its emotional state depending on what's going on screen. So we packaged all of that music engine into a Unity SDK, Unity being this game engine that's very popular among indie game developers, and so that indie game developers could actually use this music engine. One of the issues these startups faced during this era was that the market wasn't necessarily ready and the technology was quite premature, so adoption was a real problem. We can now move to the fourth era that I call Big Tech Experiments era. This goes from 2017 until 2022. We have tech giants who take notice of generative music and start using it to experiment with AI. They use generative music as a sort of playground. The focus, the technological focus, shifts towards deep learning, and they start to use massive data sets and massive computational power to create these large deep learning architectures. They don't have commercial goals at this point, and as I mentioned, they tend to use generative music as a sort of test ground for seeing what's possible with AI applied to a creative space. Here you have some companies that chipped into the generative music research thing. Like for example, Magenta from Google Brain, OpenAI, Amazon, and IBM Watson. Let's take a look at a couple of these experiments. We'll start with AWS Deep Composer, which was not just a piece of software, but also this piece of hardware here. And Amazon would sell this as a way for dragging developers into machine learning and for letting them see how cool machine learning and deep learning is, and let them see the possibilities that go beyond the typical, I don't know, like NLP, natural language processing stuff, and they also venture into creative things. So it was more of a marketing stunt, this product, than anything else. In 2020, OpenAI published Jukebox, and this was a turning point in the history of generative music, because this was an amazing model that for the first time demonstrated the full potential of raw audio generation. So what's raw audio generation? Well, the idea basically is that you train a model directly on the waveforms or some transformation of those waveforms, and then you get out of the model directly waveforms, directly music you can listen to, no longer scores. And we'll talk about the difference between symbolic and audio generation in a dedicated video in a future lecture. Now, Jukebox used advanced deep learning. This model is able to generate a full piece of music, also with lead vocals in it. And it's quite impressive, the result. And of course, given you have a full waveform as an output, there's a lot of performance details that get embedded. And as I said, this was a turning point for the history of generative music. Let me show you an example. Okay, so here we have Jukebox SoundCloud. Let's listen to this.
Don't you know it's gonna be alright? Let the darkness fade away.
So as you can hear, this is quite impressive, especially for that time. And you can still hear some artifacts, but this was a turning point, because all of a sudden we realized that it was possible to generate full pieces of music just training complex models with a lot of data, audio data. Then something incredible happened in 2023, where people started to notice that generative music can literally change music forever. This is when the music AI hype started, and we don't know when it's gonna end. What's this era about? Well, as I said, the music industry is on fire. If you go to any music conference, you'll have one or more panels or talks about generative music or music AI in general. Now we have big corporations that are starting to explore the commercial viability and opportunity of generative music. And I would say the technology has become mature enough to be scalable and to provide a product that people want to buy at this point. But in order to build these large deep learning networks, you have to have massive music datasets. You have to create these datasets, and there are a lot of legal and ethical implications there. We're going to address some of this in a future video. But what all of this means is that it tends to be quite difficult for smaller players to play the game, because the barriers to entry are quite high. But regardless, we have a whole new startup wave. A lot of new startups, generative music startups, are popping up these days. But why do we have this generative music hype right now? Well, there's an elephant in the room here, isn't there? And that is generative AI. ChatGPT has completely changed the perception that people have, that complete industries have about artificial intelligence. So now people are way more open to AI adoption, and that is also true in terms of music AI adoption. This revolution is not only carried by OpenAI and ChatGPT, but also by other companies and other generative AI modalities, like for example, text to image generation. You can use DALL-E 3 at this point, you can use Midjourney, you can use Stable Diffusion to generate amazing images just by typing what you want, and the algorithm is going to generate an image that hopefully will reflect the prompt that you input initially. And now this idea of text to image translated to text to music, so text to music generation. So now you have models where you can just issue a sort of textual command, like for example, give me a fusion of reggaeton and electronic dance music with a spacey otherworldly sound. You can issue this command to a music model and you're gonna get like a full piece of music, or at this point I should say more a passage of a piece of music that hopefully will reflect the initial prompt. We have a lot of really cool experiments and products at this point that work really well for text to music generation. An interesting text to music system is MusicLM, published by Google in 2023. Obviously, I've already covered this model and I'm going to leave you the link up here if you want to get to know more what it is all about. But let's listen to some of the results here. So for example, here we have this caption. So give me the main soundtrack of an arcade game. It is fast-paced and upbeat and blah, 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 right? So let's listen to the result. Yeah, the result is quite impressive. And as you can hear, there are way less artifacts than there used to be with Jukebox. Later this year, Meta published another amazing text-to-music model that's called MusicGen, and we can take a look at this. This leverages large language models, and it's quite impressive, the result. So let's listen to this prompt. So give me a grand orchestral arrangement with thunderous percussion, epic brass fanfares, and soaring strings, and so on and so forth. Let's listen to the result. The result is quite impressive at this point. From the start of the music hype era, it's amazing to see the quantity and the quality of the models published every month. Only in January 23, we had a ton of new generative audio models, like for example, Muse AI, Audio LDM, SingSong, Rave2, Refusion. It's incredible the amount of new models released every week at this point. During the music AI hype era, there's been a renovated interest in generative music companies. And indeed, we can talk about a second startup wave with some of these companies that you can see here already quite established. A lot of people are also trying to create new startups from scratch. And the great thing is that now we start to see a sort of framework behind generative music. For example, a few months back, YouTube announced a partnership with Universal Music Group to create a music AI incubator. And earlier this year, in April 2023, we had the first cohort of the Sound of AI Accelerator, and we incubated 10 music AI startups, and some of these were generative music startups. Okay, folks, we are at the end of this historical journey. Congrats for getting until the end of this lecture. By now you should know that there have been 5 different eras of generative music. It all started with manual algorithms. Then we moved on to the academic era, and at this point from the mid-50s until the end of the 2000s, we had a lot of researchers pouring their hearts into algorithms that could create music autonomously. Then we moved to the third era, that is the first startup wave of generative music companies. Then from 2017, we saw the tech giants got an interest into generative music and started to experiment with it, starting using generative music as a sort of AI playground. Finally, in 2023, we entered the music AI hype era. Before I dash off, let me remind you a couple of things. First, it'd be great if you could hit the like button, and if you're not a subscriber of the Sound of AI channel, consider subscribing and activate the notification bell so that you'll get all the lectures in this generative music AI course. If you have any questions about this lecture or the course at large, feel free to leave them in the comment section below. Or if you want to get deeper, remember that there's the Sound of AI Slack community, and there we have a dedicated channel that's called Generative Music AI course, where you can interact with other students, and I'll be there to answer your questions as well. Finally, next time we're going to dive deep into different generative music use cases. That's all for today. I'll see you next time. Take care.